In this episode, we're going to put all the earlier collection ideas into motion by focusing on the pipeline itself, meaning the end-to-end path that telemetry takes from many different systems into a place where the SOC can actually use it. It is easy for beginners to imagine data collection as a simple switch you turn on, but in practice, it is more like building a reliable delivery network that must work every hour of every day. That network has to handle different log formats, different timestamps, different levels of sensitivity, and different rates of data, all while staying secure and not breaking the systems it observes. Efficiency matters because a pipeline that is too expensive, too slow, or too fragile will eventually collapse under its own weight. And security matters because the pipeline often carries sensitive evidence that attackers would love to steal or manipulate. The goal here is to help you build a clear mental picture of what a secure, efficient pipeline looks like, so you can reason about design trade-offs without needing to memorize specific tools or vendor architectures. By the end, you should be able to explain what must happen at each stage of collection and what good operational habits keep the pipeline trustworthy. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A data collection pipeline starts at the source, which is where events are generated, and the first orchestration decision is how those events will be captured without disrupting normal operations. Some systems can generate detailed logs by default, while others require configuration to enable auditing, and enabling too much can create performance issues or excessive noise. A secure approach begins by collecting the events that matter most for your use cases, then expanding gradually as you validate value and capacity. You also need to ensure that the source has stable identifiers, like consistent user and host fields, because a pipeline can transport data perfectly and still be useless if the data cannot be correlated. Time is another source-level concern, because if systems are not synchronized, investigations become confusing and correlations become unreliable. Orchestration at the source also includes thinking about where logs are stored temporarily and whether an attacker could erase them before they leave the system. A pipeline that depends on local storage for long periods increases risk, so one strong habit is to move events off the source quickly while still maintaining enough buffering to survive short outages. Once events exist, the pipeline needs a collection method, and it helps to think of this as choosing between pull and push behaviors, even if you never use those exact labels. In a push-like pattern, the source or a lightweight component near the source sends events outward to a collection point, which can reduce delays and protect integrity by getting logs off the system quickly. In a pull-like pattern, a central collector reaches out to sources and retrieves events, which can simplify management in some cases, but can also create scaling and permission challenges. The right choice depends on the environment, but the orchestration goal is the same: reliable delivery, minimal disruption, and clear accountability for success or failure. Delivery also has to handle bursts, because incidents often create higher event volume, and a pipeline that collapses exactly when you need it most is a major weakness. This is where buffering and backpressure concepts matter, because they describe how the pipeline behaves when it is under load. For beginners, the key is to remember that collection is not just about connectivity. It is about predictable behavior under normal and abnormal conditions. After collection comes transport, which is the movement of data across networks and boundaries, and security becomes especially important here because telemetry can include sensitive operational details. Transport should protect confidentiality so that logs cannot be read in transit by unauthorized parties, and it should protect integrity so that logs cannot be altered without detection. It should also support authentication between components so that a collector can trust that a source is legitimate and a source can trust that it is sending to the correct destination. Even without getting tool-specific, you can reason about transport security by asking whether data is protected during movement and whether endpoints are verified. Efficiency matters here as well, because transport must handle high throughput without creating network congestion that impacts business services. Some telemetry can be compressed or batched to reduce overhead, while other telemetry may need near real-time delivery for high-risk use cases. A strong pipeline design chooses transport behaviors that match the criticality of the data and the needs of the SOC. When you evaluate a pipeline, it is useful to ask what happens during a network outage, because that reveals whether the pipeline has safe fallback behavior or whether it loses data silently. A major orchestration challenge across diverse systems is normalization, which is the process of making different event formats understandable in a consistent way. Different systems will describe the same concept differently, such as a username, a host identifier, an IP address, or a success state. And without normalization, your analyst will struggle to connect events across sources. Normalization does not mean forcing everything into one perfect schema immediately, because that can be slow and fragile, but it does mean ensuring you have consistent fields for the key correlation points your use cases depend on. A practical approach is to prioritize normalization for identity, asset, time, and event type, because those are the anchors that support searching and linking. Parsing is closely related, because raw logs may be unstructured text that must be turned into fields, and parsing errors can silently drop important context. Diverse systems also change over time, so orchestration includes managing version drift, where updates alter event formats and break parsers. This is why monitoring the health of normalization and parsing is not optional, because a pipeline can be fully running and still degrade coverage if fields stop populating correctly. Storage and indexing is the stage where collected telemetry becomes usable, and orchestration decisions here affect both efficiency and investigative power. If you store data in a way that supports fast search and correlation, analysts can move quickly during triage and incident response. If storage is poorly organized, investigations become slow, and the SOC may miss patterns simply because queries take too long or return incomplete results. Efficiency pressures show up here strongly, because high-volume data can be expensive to store and index, and not all data needs the same retention or the same search performance. A mature pipeline often applies tiering, where the most valuable and most frequently used data is kept in fast access storage, while older or lower priority data is retained in a cheaper form for longer-term look-back. Even without naming technologies, the principle is that storage should match the value and usage of the data, not treat all telemetry as equal. Orchestration also includes ensuring that storage is protected, because central telemetry stores become high-value targets for attackers seeking evidence or sensitive information. Protecting storage with strong access control and monitoring is part of making the pipeline trustworthy. A secure pipeline also needs careful access design, because many components require permissions that could be abused if they are too broad. Collection components often need to read logs or subscribe to event streams, but they should not need to administer the systems they observe. Transport components need to authenticate and communicate, but they should not be able to access unrelated data stores or modify detection logic. Central storage and analysis components should separate roles, so that people who search data do not automatically have the ability to change how data is collected or to disable sources. This is the principle of least privilege applied to the pipeline, and it reduces the impact of compromised credentials or mistakes. For diverse systems, access design can be tricky because each platform has its own permission model, but the orchestration mindset stays consistent. Grant only what is needed and document why it is needed. You also want to manage secrets responsibly, because integrations and collectors often rely on keys or tokens, and those become shortcuts into many systems if mishandled. When you review pipeline security, always ask what an attacker could do if they compromised one component, because that reveals whether privilege boundaries are meaningful. Efficiency is not only about cost, it is also about the reliability and manageability of the pipeline over time, especially as sources grow and change. Diverse systems produce different volumes, so orchestration includes capacity planning, where you anticipate peak rates and ensure collectors, transport links, and storage can handle bursts. It also includes filtering, which means deciding which events are worth collecting at full detail and which can be summarized, reduced, or excluded because they do not support your use cases. Filtering must be done carefully because overly aggressive filtering can remove evidence needed for investigation, but zero filtering can drown your platform and your analysts. Another efficiency habit is to standardize collection patterns when possible, so you do not build a one-off pipeline for every system, because one-offs are difficult to maintain and easy to forget. Standardization might include consistent tagging of source types, consistent field naming, and consistent health checks across collectors. When pipelines are standardized, onboarding a new source becomes faster, and troubleshooting becomes easier because patterns repeat. Efficiency, in this sense, is about reducing complexity so the SOC can keep the system healthy without heroics. Observability of the pipeline itself is one of the most important ideas to cement because you need to know when your monitoring system is failing. Observability means you can see whether sources are sending data, whether collectors are receiving it, whether parsing is successful, and whether delays are growing. It also means you can measure data completeness, such as whether key event types are present and whether key fields are populated. Without observability, you might believe you have coverage while you are actually blind, and that false confidence can be more dangerous than knowingly having a gap. Observability also supports rapid troubleshooting, because when an event stream goes quiet, you can identify whether the issue is at the source, at transport, at the collector, or at storage. For beginners, it helps to think of the pipeline like plumbing, where you need gauges to know pressure and flow, not just a belief that water is coming out somewhere. Pipeline health monitoring should produce actionable alerts, such as source silent conditions, sudden spikes, parsing error increases, or excessive ingestion delay. This is how you keep collection trustworthy over time. Diverse systems also raise the issue of data sensitivity and segregation, because not all telemetry should be treated the same from a privacy and governance perspective. Some logs might include personal information, business transactions, or sensitive operational details, and those require careful access controls and sometimes additional handling like redaction or minimization. Segregation can mean separating datasets by sensitivity, limiting who can query them, and ensuring that monitoring outputs do not unnecessarily expose sensitive content. It also means being careful about enrichment, because enrichment can add sensitive context to otherwise harmless events, increasing the overall sensitivity of the dataset. Governance is not just paperwork, because it affects whether stakeholders trust the SOC to collect and handle data responsibly. A secure pipeline design makes these considerations part of the orchestration plan rather than an afterthought. This approach also protects the organization from creating new risks, such as collecting sensitive information into a central store that is accessible too broadly. When you prioritize secure habits, you are not weakening monitoring. You are making it sustainable and defensible. Change management is another orchestration requirement that becomes more important as the pipeline spans many systems. Systems get updated, logging formats change, new services appear, and old services are retired, and each change can affect collection quality. A pipeline that works today can silently fail tomorrow if a parser expects a field that was renamed or if a logging source changes its event categories. This is why controlled changes, testing, and review are valuable, even if you keep the process lightweight. You want to know what changed, when it changed, and what effect it had on coverage, because that supports rapid correction when something breaks. For beginners, it is useful to recognize that pipeline issues often show up as detection issues, such as a sudden drop in alerts or a flood of parsing errors, and those should trigger pipeline investigation, not just alert tuning. Strong orchestration treats the pipeline as a living system that needs routine care, not a one-time build. When change is expected and managed, you avoid the panic of discovering blind spots during an incident. As we wrap up, keep the end-to-end picture clear. A secure and efficient data collection pipeline begins at the source with careful logging choices, moves through reliable collection and protected transport, and becomes usable through normalization, storage, and search. Orchestration is the discipline of making those stages work together across diverse systems, while keeping security boundaries, least privilege, and responsible handling of sensitive data in place. Efficiency comes from standardization, capacity awareness, and purposeful filtering, which reduce cost and complexity without sacrificing the evidence needed for decisions. Trust comes from observability, meaning the pipeline monitors itself so you can detect when visibility degrades before an attacker or an outage exploits the gap. Over time, change management keeps the pipeline stable as systems evolve, and governance keeps the program defensible and trusted by the business. If you can explain these principles and how they connect, You can reason through collection pipeline scenarios on the exam, and, more importantly, you can design monitoring that remains reliable when it is tested by real stress.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.